Now let's talk about PostgreSQL JSON improvements. PostgreSQL 17 expands the existing features related to work with JSON data. We are going to talk about JSON table, which is a function which basically converts JSON data into a relational table format, thus simplifying your work with it within a SQL environment. So you can query it, or you can, for example, use it in your DML statements. And the benefits of this new improvement include flexibility in working with various data formats under the umbrella of the same database engine. So if you want to use only PostgreSQL to work with data, here you go. So what is JSON? And this is a good question for us who are used to this format for more than a decade. As per Wikipedia, JSON or JavaScript object notation is an open standard file format and data interchange format that uses human readable text to store and transmit data objects consisting of name-value pairs and arrays, which is quite a boring definition. If we look at the example on the bottom of the page, this is what JSON documents look like. So you see that those curly braces are used to define an object with two attributes. Their names is on the left of the column and their value is on the right. So here we have two attributes. The one of them is a simple string and the other one is an array. Now, what PostgreSQL added in this version is JSON table function, the function which is going to make your life so easier if you work with JSON in the database. This function allows you to query JSON data and present it as a relational data set, which can be accessed as a regular SQL table or view. You can use it inside the from clause of a select, update, or delete, and as a data source in a merge statement. For those of you who for some reason missed that, yes, we have merge in PostgreSQL. Taking JSON data as an input, JSON table uses a JSON path expression to extract a part of the provided data to use as a row pattern for the constructed view. And we are going to see it in a couple of moments in a more practical example. Each SQL JSON value given by the row pattern serves as a source for a separate row in the constructed view. From a developer's perspective, JSON table significantly simplifies working with semi-structured formats, and we will show you why. So this is a syntax tree. It may look a bit overwhelming, but there is nothing complicated actually happening here. So we have the context item where we are going to take our JSON formatted data from. We have a path expression, like which part of this JSON formatted data we are going to parse and use. And we have this passing syntax. This is the value, and we can actually have multiple values here. We have columns. Each of them represents a relational table column, which we are going to get as a result. And also what to do when, for some reason, we face some error in the data. So for some reason, the data is invalid. For JSON table column, as you can see, we have quite a broad variety of options. So we have path expressions. We can decide to keep or omit quotes on string values, which we can get from this JSON. We can decide what to do with nesting if we want to. So we want to take some part of the JSON which is nested in the JSON, which is nested in the JSON. And now we are going to jump to the more interesting part, which are examples. Okay, so here is our first example, which covers passing for ordinality, path, and exists clauses. As you can see on the screen, we have the query, which queries JSON formatted data and tries to display it as relational data. In our document, we have a single attribute with an array of two records, apple and banana, and we pass in a value as a variable which is used on the line below. This variable is called a price limit, and we want to show all the variables where our price limit is greater than 15. We also have row num for ordinality. This way we add in a sort of a calculated column. So for each new record, we increase this number by 1, and you can see it as the first column in the result. Pass clause is used to specify that we want to show price as our column, and item as our column called item name. This way we can rename attributes if for some reason we do not like their current attribute name. And we also can use exists, which is used in the last line of the column part. So this is our filter with this variable. Let's move to the next example. The next example is about nesting. So we actually have JSON data inside the JSON data, and we want to dive into this document and extract this data from the depth. So here we have the nested paths, as you can see on the line, starting with this clause. And we specify that we want to get items as a separate table, because we have the document where orders is an array of independent separate JSON objects, and we need to get to them with this nested path expression. And here is the result of this query. As you can see, we can bind order ID to the specific item from this order on the same screen, the same way as if we worked with relational data into tables. The third example shows you how to query JSON from a table. So here we store our JSON formatted data in a table, which is created with the first statement. We add in two different rows there, the row with a user named blue and the row with a user named unblue. We are not too original. And then we are trying to select this data from the column with JSON values in this query. So as you can see, we can pass the name of the column, which is the first parameter to JSON table called JSON data. We also provide the JSON path. So we want to look for a user attribute, and we specify two different columns for those users, username and user age. To summarize what we've just seen for JSON table, as you can see, for a developer whose daily work is connected with processing, querying, updating, and displaying JSON data, this new feature brings more value and gives more flexibility.